Chairman of the Board for the European Processor Initiative. I'm very happy to be with you today for the Linaro virtual event that we are running all together, considering the circumstances. In this presentation, I will give you some more information about the European approach for Exascale solutions based on European technologies. Everything started back in 2015 from an initiative by Jean-Claude Juncker, who was president of the Union. And Jean-Claude Juncker wanted to have, by 2020, a European Exascale machine, the top 3 in the world, based on European technology. That was reinforced in 2017 with the creation of EuroHPC, who is the organization federating the 27 countries plus a few others for they can share the same strategy in the high-performance computing field. Then, yesterday, the new president of the Union, Ursula von der Leyen, explained that the objective to have technological sovereignty in high-performance computing is even more important than before, and the Union is going to invest during the next 6 years about 8 billion euros for developing supercomputers and the technologies for supercomputers. This is why, and this is exactly what she said, we want to have the European industry to develop our own next generation microprocessor that will allow us to use the increasing data volume on energy efficient and security systems. That is crucial for Europe, and from this perspective, what we have started with the European Processor Initiative is exactly what will become the central piece of the European strategy in data and IT technology for the future. So, when we translate all of that into concrete objectives, EPI has as an overall strategy to develop a complete European design high-end processor addressing different fields from supercomputers to edge HPC segments. So we need to address that with different approaches. In the short term, we need to supply European design microprocessors based on the best IP available on the market to empower the European Exascale machines. And we also have a long-term objective to develop our own IP in order we are not at risk of embargo. So EPI has a unique feature in the sense that we combine the short-term objective with high TRL with long-term objectives starting with low TRL. And we have a magic combination between all the members of the project to reach those objectives. So how do we implement that? We have a roadmap to develop right now based on ARM instruction set, high-end microprocessor that will be in the European Exascale machines. This is based on the ARM Zeus core, and that will be manufactured by Cyper, our industrial hand, in a 7 nanometer manufacturing process, and we plan to have by 2022 the general availability of the processor in order they can be in the European Exascale machine in 2023. And then we'll move forward with our next gen microprocessor also based on ARM instruction set on ARM architecture. In parallel, we start developing our own instruction set based on RISC-V. Today, this is with low TRL, and through time, post 2026, 2027, we plan to reach high TRL and to have the potential to build up our own microprocessors in the high-end segment based on this technology. And those two different instruction sets will merge, will fusion together in a single platform that we call the common platform. The partners we have in the European Processor Initiative are the following ones, and I will not describe all of them in detail. Just a note to mention SiPearl, which is the industrial hand that has been created just for the industrialization, the manufacturing, and the selling of the technology we are developing in the European Processor Initiative. So basically, we have a transition between EPI, with the development of IPR, to products developed by SiPearl based on EPI technologies. And I will not describe that in detail, but anyway, you can see here the very strong connection between the development of technology in EPI and the industrial aspects with SiPearl. Now, let's talk about technology. The vision we have for exascale machines is presented on this chart. We believe that the future exascale solutions must be workflow engines, combining in a single framework the information, the data, coming from the world, from IoT systems, combined with edge computing systems, and combined as well with public clouds. And all of that will be merged together in complex workflows that will be run and operated in massive exascale class or post-exascale class supercomputers. So to be efficient, we believe that those exascale machines must combine totally different technologies. They must have general purpose processors plus different class of accelerators. Some of them GPU, so we could have different GPU in the machine for artificial intelligence stuff, but a general way. We could have as well FPGA. We could have as well neuromorphic solutions, or we could potentially have in the future quantum accelerators. So we believe that the main strength of the ARM ecosystem is very visible on this chart. We have ARM that is dominant in the IoT field and also in the edge field. We start seeing ARM visible in the cloud solutions. We start seeing solutions from Ampere, from Marvell. It is known that Amazon is working on ARM-based solutions. And in the field of supercomputers, Fujitsu has developed an ARM-based high-end microprocessor. We are developing a high-end HPC microprocessor as well. So we believe that there could be a seamless continuum based on ARM solutions from IoT to supercomputers. And we believe that the design of our processor have to implement that possibility to get different accelerators. So what does it mean, to be very concrete? It means that the general purpose processor has to be able to combine in a single framework different accelerators. GPU from vendor A, GPU from vendor B, neuromorphic systems, FPGA, and so on and so forth. And then, as a direct consequence, the flop engines, the lean pack engines, will be moved to very specific devices, and that will move to the accelerator space. So how do we implement that at the technological level? So we have a concept of common platform. On this common platform, we have a floor plan, multi-die floor plan, on which we connect different general purpose processors, here from ARM based on Zeus, on which we could have the European accelerator prototype we develop. We could embed FPGA, we could embed specific accelerator solutions, here for instance from Carre. We could embed cryptographic engines, and so on and so forth. On this common platform will be connected to external world through HBM memories, DDR memories, PCI Express Gen 5, or potentially in the future CXL, so through CCX as well, high serial links, and also with die-to-die connections. So we believe this is the only way to be integrative and to offer to the supercomputer manufacturers onto the field the most integrative solution that could work in the post-exascale area. So now let's move to the perspectives and challenges for the future. First point, we have to celebrate the fact that EPI is going to deliver. We have rebuilt in Europe the expertise to develop high-end and complex processors. And this is the very first success from the European Processor Initiative. The second success will be the development of a general-purpose processor by Cyper combined with EPI technology, and that will become the central piece for the European Exascale machines. So we'll be ready to develop in the futures, over the next 5 to 10 years, a European-made, fully made European processor based on European technologies. So now let's be also very pragmatic about the news, the new situation that we are facing. Nvidia is likely to acquire ARM. Is it a challenge? Is it an opportunity? Nobody knows yet. But anyway, this is a fact and we have to build from that. So we believe in the European Processor Initiative that it is more an opportunity than a threat. Indeed, we believe that combining together ARM, which is the general purpose technology for the whole data flow, with Nvidia artificial intelligence, IP and technologies, could offer a unique combination for us. It doesn't prevent us to keep developing our technology or to integrate specific accelerators that could make sense for some aspects of the workflows. But anyway, we think that combining together ARM with Nvidia could offer a fantastic combination for making the continuum at the data level much easier for everyone, from hardware developers to end users. So I thank you for your attention. And if you have any question and if you want to know more, you can contact us through our different media. We have a website and we are also visible on Twitter and LinkedIn and on YouTube. Thank you very much for your attention.